Today we're going to talk about decimal divisors. By the end of this lesson, you should be able to say, I can divide when there is a decimal in the divisor. Every division problem can be translated into a question. For example, 16 divided by 8 can be translated into the question, how many 8ths can fit into 16? Let's look at this with models. If I had 16 holes and groups of 8 rocks, how many groups of 8 rocks would I need to fill each hole? 1, 2. So how many 8ths can fit into 16? 2. 12 divided by 4 can be translated into the question, how many 4s can fit into 12? Let's look at it again with models. If I had 12 holes and groups of 4 rocks, how many groups of rocks would I need to fill each hole? 1, 2, 3. So how many 4s can fit into 12? 3. Let's take a look at this same idea with a fraction, and fractions can be turned into decimals. 5 divided by 1/2 can be translated into the question, how many halves can fit into 5? Well, if I only have half a rock, I need to find another half to fill the one hole. So 2 halves are needed to fill each hole, and if I'm looking at these 5 holes, I would need 10 rocks. This seems strange that when I'm dividing I get a bigger number as my quotient, but it makes sense because I need more of the piece that I'm using to fill the hole to fill up one hole. So it's going to take even more to fill up multiple holes. Take out your calculators and try these 3 questions in your calculator. What do you notice about each of the quotients in these division problems? They're all the same. Let's look at some more. Try these problems in your calculator. Looking at each of these quotients, you'll notice you get 60 each time. It seems strange that we would get the same quotient for 3 different problems that look very different. However, it makes sense if I ask myself the question, how many times does 200 go into 12,000? The answer is 60. If I take 2 smaller numbers, how many times does 20 go into 1,200? It still goes in 60 times. Same is true with how many times does 2 go into 120? The answer is 60. So although these problems look different, their quotients can still be the same. Let's look at another set of examples. Pause the video and try these 3 in your calculators. You'll notice that each of these quotients are 5. So even though the problems look different, their quotients are still the same because we're asking ourselves how many 7s go into 35, how many 70s go into 350, and how many 700s go into 3,500. So their quotients can be the same. What is the question that we'll ask when we look at this problem? How many 500ths fit into 10? I can think about this as money and ask myself, how many nickels make up $10? Before I go into finding out how many nickels make up $10, I might want to ask myself, well, how many nickels make up $1? And the answer is 20. So if I need 20 nickels to make $1, how many nickels will I need to make $10? And the answer is 200 nickels make up $10. Therefore, 5/100ths fits into 10 200 times. Notice how these problems look different, but the result is the same for each quotient. Now let's look at the decimals in those problems. I can use this concept of different problems resulting in the same answer to help me divide by a decimal. So if I have a problem like 48 divided by 8/100ths, I know that that could be the same as 8 divided by 480. And if I know that 8 divided by 480 divided by 8 is equal to 60, then I know that 48 divided by 8/10ths is equal to 60 as well. Let's look at another example. 45 divided by 9/100ths. I know that that's the same as 450 divided by 9/10ths and 4,500 divided by 9. They're all going to give me the same quotient of 500. Notice what happened to the decimal in each of these problems. When I started out down here with 45 divided by 9/100ths, I took the decimal and moved it one place to the right to get 9/10ths. If I move it one place to the right to get 9/10ths in the divisor, I have to do it in the dividend as well. Since my decimal's at the end, my decimal then gets moved over one place to the right, and I need to add a 0. I can do that again so that 9/10ths becomes a whole number. This is going to be very important when we are dividing by decimals, because each of these gets 500 as a quotient, and we're going to use this to help us out. It might seem weird that this quotient is so large, but think of it as money. How many times can 9 cents fit into $45? And the answer is you would need 500 groups of 9 cents to fit into $45. When we're dividing by a decimal, we can change the problem so that the divisor is a whole number. I would multiply the divisor by 10 to make it a whole number. And look what happens when I multiply 7/10ths by 10. I get 7. But if I change the divisor, I have to change the dividend. I have to do the same thing. So I would multiply 35 by 10 and get 350. Now I can divide 350 by 7 and get 50. That would be the quotient for this problem. So, since 350 divided by 7 is 50, then 35 divided by 7/10ths is also 50. Whatever you do to the divisor, you must also do to the dividend. So, to turn 6/100ths into a whole number, I need to multiply the divisor by 100. Notice, when I read this as a decimal, 6/100ths needs to be multiplied by 100. And if I multiply the divisor by 100, I must also multiply the dividend by 100. So I would think of this problem as 2,400 divided by 6. When I divide that, I get 400. So 24 divided by 6/100ths is also 400. Try these next 4 problems. First, move your decimal as needed, then do the division. Pause the video and complete these problems in your notebooks. Don't forget to WSQ as well.